evaluating multiple choice question exam using reliability test in Excel and SPSS based on Cronbach's alpha equation. Reliability test for multiple choice question exam in Excel using Cronbach's alpha. Reliability test measures the internal consistency of items, i.e. the score's consistency. If a group of students, the same group of the students, repeated the same exam, the same questions at different occasions, their score or scores for both occasions are similar, and that indicate that the exam or the test is consistent and reliable. And the way to calculate the reliability of an exam as a whole or a test is to use the Cronbach alpha. This is one of the method for reliability test, and the equations for that is as given here. Alpha equals to k divided by k minus 1, as k represent the total number of questions. This multiplied by 1 minus the sum of the variance for each individual question or item divided by the variance for the total score. Here in Excel data sheet, I have a data extracted from an exam and a test for 10 students answering 15 multiple choice questions, and the score for each question was recorded as either 1 or 0. 1 stands for correct answer, 0 stands for wrong answers. So these data are dichotomous data, binary data, just two options, correct or wrong. And to determine the reliability of the exam as a whole, we're going to use the Cronbach alpha equation to generate a value for the alpha. A value of the alpha does range from 0 to 1. 0 indicates that the test or exam is unreliable, and 1 indicates that the exam or the test as a whole is extremely reliable or excellent. The first step in calculating the reliability is to calculate the total score achieved by each individual participant or student. In this case, i.e. to add all the scores achieved by each individual student. And the way to do that, in this new cell, we're going to label this cell or this column as total score, and to calculate the total score for each individual participant, select the cell, then select the sum symbol here, and select the range of the data to combine and add from question number 1 to question number 15. And if we click on enter, the total score for the first student is calculated. To calculate the rest of the scores for the rest of the student, we're going to select the value here, hold, drag to the last student, and the Excel will auto fill and auto calculate the value for the total score for each individual participant. Now we have calculated the total score achieved by each individual participant. The next step is to calculate the variance for the total score, i.e. the variance for these scores. So if we select this cell and then insert the equal sign and then type VAR for variance and select the first options here, and then select the range of the data to determine the variance for, and then click enter, a value of 22.36 or 36 is generated. So this is the variance for the total score. The next step is to calculate the variance for each individual questions. So each one of these questions, Q number 1 to Q number 15, we're going to calculate the variance for those variables. And again, it is the same concept. If I'm going to type here variance and then select this cell, in this cell I'm going to insert the equal sign and then type VAR, select the first option here, and then select the range of the data. Select the range of the data for question number 1 to determine the variance for it, and click on enter. A value for the variance for the first question is calculated. To calculate the variance for the rest of the questions, just click on the value here, hold, drag to auto calculate and auto fill the value for the variance for each specific questions. Now we have calculated the variance for each questions. The next step is to add them all together. So what I'm going to do here in this cell, I'm going to select this cell, then select the sum as I'm going to add them, and then select the variance for the 15 questions. And if I click on enter, a value of 3.42 is generated. This is the value for the sum of the variance for the questions. Now we have most of the component of this formula ready. For the K represent the number of questions. So here we have 15 questions. And for the variance for the total score, we have calculated that to be 22.336. Just click, right click, copy, and then we're going to paste this value using this option here. So we have now all the component for the formula ready. The next step is to calculate the alpha value. And the way to do that is to insert the equal sign and then open one bracket multiplied by the second bracket, and in the first bracket I'm going to add the K. The K is 15 divided by 15 minus 1 is 14, so I'm going to divide that by 14, and then in the second bracket here I'm going to add 1 minus the first value of the sum of the variance for the items, selecting this value here and then dividing that by the value for the variance for the total score and clicking the enter key a value of alpha equal to 0.908. So this value means that the exam or the test is 91% reliable, and that is a good result and good value. So here if we look at the table, we can see that Cronbach alpha value has different ranges, and each ranges will be represented by reliability. If the alpha value is equal to 0.9 or greater, then the reliability is excellent. If the alpha value is between 0.8 and 0.89, it's a good reliability. A value of 0.7 to 0.79 is acceptable reliability. A value of 0.6 to 0.69 is questionable reliability, and an exam or a test that has a alpha value of 0.5 to 0.59 is considered to be a poor reliable exam. A value of less than 0.5 indicate that the test is unacceptable and unreliable. So this is the way to do the reliability test based on the Cronbach's alpha, using the formula given here by calculating the variance for each questions, adding them together, divided by the variance for the total score. Reliability tests for multiple choice question exam in SPSS using the Cronbach's alpha formula. Reliability test measures the internal consistency of items and the scores consistency. If a same group of students repeated the same exam with the same questions, multiple choice questions, at different occasions, their scores in both occasions will be similar, i.e. the exam or the test will be consistent and the scores will be consistent, and the exam or test will be reliable. So there is a consistency of scores between those two occasions. So reliability test based on Cronbach's alpha assess the exam and the test based on the equation below to determine the reliability of the test. This equations equal to K divided by K minus 1. K stands for the total number of questions, then multiplied by a bracket 1 equal within the bracket 1 minus the sum of the variance for each individual questions divided by the variance for the total score. Here in SPSS I have a data extracted from an exam result for 10 students answering 15 multiple choice questions, and the score for each question is recorded as either 1 or 0. 1 stands for correct answer, 0 means wrong answer. So these data here are dichotomous data. That means a binary data, only two options, correct or wrong. And to determine whether this tests that have these questions in it are reliable. So we're going to do reliability tests based on the Cronbach's alpha and based on the formula just described shortly. And to do the test, the first step is to calculate the total score achieved by each individual participant or student. And that can be done by combining all the scores for the 15 questions answered by each individual student. And to do that is to click on transform, compute variable, and then in the window for target variable we're going to call it total score. And the total score is the sum of all the scores achieved by each individual student. And to use the command for the sum, we will click on the function group all, scroll down to statisticals, and then in statisticals select the command or the function for the sum. Drag the sum to here, to this numeric expression box, and then insert the variable one by one between those brackets separated by comma. So we're going to insert the first variable and then separated by comma the second variable, and then comma a third variables, and so on until we insert the whole variables that we want to add or combine together. So we need to make sure that we keep the separate the variables with a comma when we enter them. Another comma here. 11, question 11, 12. So we need to make sure that there is always a comma between variables. Right, so if we click on OK, a new variable is generated in a column for a new variable is generated in SPSS, and I'm going just to do some editing on this variable by clicking on the variable review, and then I'm going to decrease the decimal point to 0, and I'm going to convert that measures into scale, and I'm going to center that, make it into the center, and I'm going to reduce the column into 4, so to make it neat and tidy. So now we have calculated the total score for each individual student participated in the exam, and following the alpha equation here, Cronbach alpha, we need to calculate the variance for the total score. And to calculate the variance for the total score for this variables, we click on analyze, scroll down to descriptive, click on frequencies. In the frequencies we are going to determine the variance for the total score, so we drag the total score to the variable box, click on statistics. In the statistics box we're going to select the variance, click on continue, as we're only interested in the value for the variance. An output from SPSS generate two tables. One of the tables says that we have 10 participants and the variance for the total score is equal to 24.84. So if we double click on that and then highlight that and select the numbers, copy, and then bring it here to this PowerPoint, and I'm going to place the variance for the total scores in this place here, and I'm going to decrease this by 1 decimal. So we have calculated the variance for the total score. The next step is to calculate the variance for each individual questions and then add them together. To do that, here in this SPSS, we're going to select the data and do a transpose to calculate the variance for each individual question. And the way to do that is to click on data, transpose, and on this small window select Control A, select all and transfer them into the variable box, and then click on OK, and the data has been transposed in a way that all the questions now are in rows and all the students are now in columns. So I'm going to do a few editing here before I proceed with the further calculation. So what I will do, I'll click on the variable few and I'm going to decrease the decimal into 0. So I'm going to make all the values for 0 decimals, and I'm going to change the measures for each variable to scale. Every one of them, make it scale. And then I'm going to center the data into the center of the columns. So selecting this and then all centers, and I'm going to decrease the column width into, make it 4. And another modification I'm going to do is also rename the columns for the students. So to do that is to click on Control F and use the replace function, and I'm going to type VAR0 and replace that with S for students, and I'm going to do that for all the variable. And to do that, I first have to select all the variables, click on replace all, so all the variables has been renamed. Click on close, back again to data view. Now the data looks more neat and tidy. So now we have already calculated the variance for the total scores. Now we need to calculate the variance for each individual questions here, from question number 1 to question number 15. And the way to do that is to click on transform, compute data, and then we're going to call that the variance for the questions. So variance for each questions. And to do variance for each questions, we're going to select the command variance from the function group. If we click on all and then scroll down to statistical, and then in statistical, in the box below, select the variance, drag the variance into the numeric expression, and again we are going to calculate the variance for each individual students. So we're going to use for each individual questions, and if we're going to use the variables from student number 1 to 10, and the way to do that again is to insert the first variable and then separate it by a comma and we do the same for the rest. Until we reach the S10. If we click on OK, a column will be generated for the variance for each individual, calculated for each individual question. And I'm going to do some editing here for variance, is to make it center and make it scale and reduce the decimal into 0. So I'm going to get rid of this value for the totals. I'm going to keep the decimal by 2, as we are here we're having decimals, so we'll retain the decimals, 2 decimal points, so we can see the variance here. This is the variance for each individual questions. Now we need, following this formula here, we need to add all this variance for each individual questions together, and the way to do that is to click on Analyze, Descriptive, Frequency, and there we're going to select the variance for questions, drag it to the variables, click on Statistics, and then select the sum, because we are going to add all the variance for all the questions together. So if we click on Continue, then click on OK, again the variance for the 15 questions has been calculated and found to be 3.8, and I'm going to select this, or select this, copy it, and or just type it here, 3.8. Now we have most of the component required for calculating the Cronbach alpha ready. So the next step is to divide these figures to find out the product. So to do that, I'm going to use a calculator here. Using the calculator to divide 3.8 over 24.84 equal to 0.152 or 0.153. Then subtract this figure from 1. 1 minus 0.153 equal 0.847. 0.847. Then multiply this figure with k, which is the total number of questions, divided by k minus 1, which is 14, and the total number of the questions are 15 here. So 0.847 multiplied by 15 divided by 14 equal to 0.9 or 0.91. So this figure, or alpha value of 0.91, means that the test or the exam is 91% reliable, or 0.91 reliable. The value for the alpha or the Cronbach's alpha range from 0 to 1. 0 means that the test or the exam is not reliable, and 1, it means that the exam is extremely reliable. So in this case, 91%, the exam is reliable. So this is the way to perform reliability test in SPSS for a multiple choice question exam using the formula or the equation for the Cronbach's alpha, which is equal to k divided by k minus 1 multiplied by 1 minus the sum of the variance for each individual questions divided by the variance for the total score to get the value for Cronbach's alpha. So Cronbach's alpha is one of the method to evaluate the exam, the multiple choice exam questions quality.